nucleotide sequence. So lead the primer. From here, this figure you can see master, the first nucleotide, it is the rubber nucleotide. And later, you can see the deoxyribonucleotide is okay, no problem. But the first penalized by the promise. So here you can see RNA priming, the first few nucleotide and the 5 primes end of the Oxyzecas fragment are rubber nucleotides. So the DNA synthesis is primed by the RNA. That the RNA sequence and later removed. And you can see here, the DNA replicated and the first stable nucleotide, it is rubber nucleotide. How to pair each other and added to here according to the base pair. The polymers can be recognized the according nucleotides. And another thing, last times I introduced the enzymes refer to the DNA replication. Several enzymes you can see take part in the destroy the double helix structure and forms the single straight act as a temperature. Here I introduce all of you. You can see the first you can see destroys the hydrogen's bond. This is the helix. And in the proteolytic organisms and found you can see helix. You can see found the DNA, B, C, and so on. Especially, and the first two kinds of the helix, you can see the function is very clear. And also you can see DNA recognize origin point, and DNA B's destroy the hydrogen's bond. And another thing is you can see, another thing is it is a protein, and is very important. I introduce my students. You can see the DNA sequence. When you remove the deleter factors, when you destroy, remove the condition, the DNA straight may be naturally, automatically restores the double helix structure. And at that times, I introduce to all of you. You can see the DNA straight act as the temperature. The DNA straight must, it is the single straight. But the single straight can be used to act as the temperature. So, whatever is in vivo or in vitro want to act as the temperature, you must destroy the double helix structure and form the single straight. You can see here, my students pay attention to. And you can see the tuple is Morris, the helix, it is on. Destroys the double helix structure and immediately forms the single straight. And that times SSB bonded with the single straight. At that times, this kind of protein you can say make the DNA straight stable. After the unwinding the double helix. So facilitated the replication of the offspring DNA. Another thing, protected the attacking by the nucleus, endonucleus, especially for the endonucleus. Another enzymes, topoisomerase. This we introduced two kinds of the topoisomerase. Topoisomerase 1 don't need ATP, only cut one of the straight and relax the double helix structure. Topoisomerase 2, you can see, need ATP. At the same time, you can see, relax the double helix structure. You can see here. And synthesize the offspring DNA, you can say the first, you can say promise. The second, you can say DNA dependent DNA polymers. Because here, the temperature is the DNA straight. And later, we studied the reverse transcription. At that time, you can say catalyze and synthesize the DNA, offspring DNA. At that time, you can see the temperature, it is the RNA, and catalyze and synthesize the DNA. And another one you can say promise. At the beginning of this class, I introduced follow you the master. This kind of enzymes catalyzed and originated the replication and synthesize the fragment of the ribonucleotide sequence and act as a primer and later elongated the nucleotide chain. And lastly, you can see DNA ligase is very important. Synthesize for this kind of enzymes is very useful. All of the students learn, you can see synthesize Zca's fragment. This kind of the fragment you can see in the future and compensated and last left the leak. At the times the DNA ligase canalized and collected together. And another definition important, the chromosome. At the times you can see, look the figure. You can say all of this together forms this complex structure. It is the chromosome. Chromosome. What do you mean? You can say the helix, the tuberous, the SSB, the promise, it is so on. Together, you can see make and forms the replication fork and originated the replication and began to synthesize the primer. And sometimes in this cycle, here you can see forms this kind of the complex structure. It is the chromosome. Another one, you can see for the DNA polymers, you can see for the proteolytic organisms, you can see contains three kind of the polymers. DNA polymers 1, 2, 3. And eukaryotic organisms, you can see and find there are several kind of the DNA polymers: the alpha, beta, gamma, beta, and epsilon. And for the polymers, except the polymerase activity and elongated their DNA sequence, and another function is very important: exon nucleus. Yeah, maybe some still think that this kind of the function makes their uh makes their polymerase activity low usage. At that time, my students pay attention to. And this kind of the enzymes is very useful. Except the elongating the DNA sequence is no problem. And another thing, keep the conservative elongation. You can see here, the PPT, you can see the fidelity of the DNA replication. Because the DNA polymers can be selected the right the deoxyribonucleotide. And another thing, select the base pairs by the DNA polymerase affinity. And another thing is, according to the base pairs, for simple, recognize the temperature by the DNA polymerase identifies the nucleotides. Third, you can say correction the effect of the exon nucleus activity. Here you can see in this below this PPT, you can see A at the last one, you can see A paired with G. At the times, A is running. At the times, you can see the DNA polymerase began to take the exon nucleus activity and remove the A and proofreading and edit the right one. You can see here the polymerase 1. You can see the polymerase activity and the exon nucleus activity. Two direction is okay. So this have the important function. You can see proofreading the replication, filling the gap in the copy and the repair. Next chapter we study the DNA damage and the DNA damage repair. And the times we lose, you can see when the DNA is spread, when the DNA molecule, you can see destroyed, and the times you can see need repair. Under some cases, we repaired and removed. Under Properties 3, it is truly catalyze the DNA replication. Process 3 also have the function proofreading function. The 3' to 5' exon nucleus activity. So at the times you can see have the proofreading function. You can see here the polymerase 1 you can see at the times you can see can be compensated the leak. Smaller fragment you can see. And another words you can see polymerase 3 and many catalyze and synthesize the straight. And the polymerase 2 in the periodic organisms you can see polymerase 2 pay attention to only under the emergency condition and take part in the emergency repair of the DNA damage. This pay attention to the polymerase activity only under the emergency condition and take part in the DNA repair. And another thing you can see without the 5' to 3' exon nucleus activity. Many we study the polymerase 3. Polymerase 3, you can see here, I copied the figure. You can see the enzymes is truly catalyze the replication of the periodic organism. And all the times forms the heterodimer. Maybe it's just thing you can see here, stable subunit. For example, 2 alpha subunit, 2 beta, 2, and theta, 2, and the 2 epsilon, 2. So about the function, why forms this kind of the structure? Because here you can see every subunit has the coding function. You can see this 2 dimer. You see comes the 2 function. And the catalyze subunit, it is the alpha catalytic subunit. You can see this one of the dimer, you can see catalyze the leading straight. And another dimer, you can see catalyze another, it is the lagging straight. And the beta subunit, you can see act as the clamp and cut the temperature. And read the count the temperature and skip and Later, the other subunit moved along the tangent. This three kind of the enzymes compare each other. You can see here. And for the eukaryotic organisms, every kind of the polymers, you can see the function different. You can say polymers alpha, you can say synthesize the negative straight, and the beta, you can say take part in the DNA repair. Just you can say the polymers one, you can say in the prokaryotic organisms, you can say polymers one, you can say take part in the DNA repair, and here the gamma, you can say synthesize the leading straight. The alpha synthesize lagging straight. The delta, you can see synthesize the multicolors DNA. And epsilon also take part in the DNA repair. Maybe some still think here you can say dot dot dot. What mean? Maybe in the future find other kind of the DNA polymers in the eukaryotic organism. Like this, you can say staining the leak is very easy. You can see here, the red, green, red. This straight you can see here forms the leak, and last you can see the DNA ligase catalyze and use the ADB and compensated together, and still the leak. Summarize all of this, you can see the DNA in the prokaryotic organisms recognize originated site, and the helix, the DNA B and C destroys the hydrogen bond. SSB stabilize the single strand. Promise synthesize the primer. The topoisomerase relax the DNA chain. And the DNA polymerase 3 DNA replication. One, you can see repairs the leak, and the ligase negated the fragment. It is so on. Okay. Reached 10 minutes. We began to study the process in the prokaryotic organisms and the eukaryotic organisms, how to synthesize the offspring DNA.
OK，老师。
Okay, come back.
Okay,
Okay, you can see the main property about the periodic organisms replication. You can see every molecular, every cycle contains all-in-one originated point, all-in-one originated site. Study. 你的模板考我，你总结了哪些方面？你考我，我就按你的那个解答。我不知道，这个外属地，都是什么？我看是你们每届的关系大。我那天问你们，那不就是我去了？没有哦，没有的那个你们好。Also, you can say here another property you can see compared with the eukaryotic organism replication. The DNA polymerase along the temperature, along the DNA sequence, you can say along the DNA temperature, moved quickly. Here, the faster you can say here, it is the mm, uh, compared with the eukaryotic organisms, uh, the replication, periodic organisms, the replication is faster. Here you can see for the periodic organisms, the compositions originated point, the composition, the sequence studies the very clearly compared with the eukaryotic organism. You can see here, I summarize originated site. You can see what kind of the sequence act as the originated point. You can see the combing sequence. You can see the 13 base pairs sequence. You can see GATCANTTA maybe forms 3 tandem, 3 copy, and totally about the originated point sequence 224 base pair. And here you can see still kind of the classical conservative sequence. You can see 3 copies, 13 base pairs sequence. And in other words, you can see here, you can see the 9 base pairs, 4 copies, 9 base pairs sequence. The TTA, TCC, ACA. 4 copy. And this kind of the sequence have the function you can see can be recognized by the DNA. The helix A. We lose, you can see recognize the originated point. So this kind of the sequence you can see can be give the signal here begin to synthesize offspring. Beginning start from here. And here you can see how to all of this you can see how to begin to the replication. You can see DNA recognized and bonding originated site, and the DNA B unlocks the hydrogen bond and destroys the base pair. Suddenly, neither the isomerase and ATP, and that times forms the chromosome. You can see here this figure. You can see this kind of the sequence. You can see 3 tandems, 3 copies, 30 nucleotide sequence, and 4 co-pairs, 9 pairs sequence. Conservative sequence you can see here can be recognized by the DNA and begin to you can see the ADB lysis and that times begin to form the opening complex, begin to destroy the hydrogen bond. And you can see B and C relaxed and B and C bonded, and that times you can see relax, relaxed structure. And elongation, in fact, is easy. For this PPT, my students pay attention to. All the times I explain follow you that DNA polymorph 3 all the times forms the heterodimer. At that times you can see for the leading straight you can see continuous synthesize. And for another one, the lagging straight you can see moved some sequence you can see begin to synthesize. Every fragment you can see here. My students think about this. For the lagging straight, you can see synthesize behind the leading straight one occidental fragment. Synthesize. And furthermore, you can see the lagging straight, you can see long is a single straight. And again, you can see enter into the in polymorph 3 and to synthesize. Certainly, you can see here also it is the semi-discontinuous. As this property we studied at the beginning of this chapter. You can see the lagging straight, you can see synthesize, you can see is the slowly. And last, you can see termination. Here, I emphasize my students the origination, the elongation, and the termination. This, in order to study is more easily, we divide the 3 part, 3 stage. In fact, this process, it is a continuous process. And maybe some things you can say, origination, and waiting 2 minutes, begin to elongation, and rest 5 minutes, and termination, low, begin to synthesize, and originating elongation and termination. And the termination where stop also and to norms find some more conservative sequence and make the replication stop. Make the replication fork stop here. So at the times, this kind of the sequence give names terminals sequence. When the DNA polymorph moved to here and the enzyme stopped the read the temperature and stopped the replication. You can see here. Here the conservative sequence you can see, and recognized by the several kind of the protein factor. The protein molecule you can see bonded to here, and the DNA polymers moved to here and stopped and relaxed, released. At the times, the replication finished. This is the replication for the prokaryotic organism. And compared to studied, you can see eukaryotic organism. Summarize all of the you can see here, because the eukaryotic organisms, you can see the DNA molecule you can see bonded with the histone and forms the nucleosome. So at the times you can see the nucleosome structure need destroyed and so this process is more complex. And another thing is you can see the nucleosome maybe the site resynthesized is not stable. And another thing is the directional replication. And compared with the periodic organisms, you can see replication is slowly. And another thing is you can see the DNA molecular you can see synthesized at the same time synthesize the histone protein. Because synthesize offspring DNA and immediately and quickly and lead and another different to the periodic organism. Multiple every molecular you can see contains stable oriented site. For this, you can see doing many research for the ester is more and find some special sequence and find some special factor take part in the replication. And another definition and doing some scientific research and find for the ester genome contains the autonomously replication sequence. You can see here the autonomously replicated sequence of the in the ester, which can be recognized by the starting complex and the starting oriented point of the replication. So here stem to the originated site in the periodic system. Here you can see this for the eukaryotic organisms, the polymers, you can see, and to now find the alpha, beta, gamma, delta, and epsilon. The function different. Polymers alpha, you can see, originated and have the function, the parameters. And polymers beta, you can see, similar to the polymers 2 in the periodic organism. Gamma, you can see, catalyze and synthesize mitochondrial DNA. And delta, you can see, it is the many polymers. And these enzymes have another function, the helix activity. And polymers 1 in the periodic organism. And another kind of the and recent years find is very important protein. It is the proliferation of the steel nuclear antigen. This protein you can say assists the DNA polymerase data bonded with the temperature and enhance the DNA polymerase data elongated activity. And the DNA polymerase alpha synthesize the primer. So other process is not very clear, and all of the scientists think the process similar to the periodic organisms replication. similar to the periodic organisms. And another sequence, another DNA structure, it is the telomer. Telomer, the DNA catalyzed and synthesized, catalyzed by the telomeres. You can say telomeres. This kind of the enzymes contains the protein, contains the enzyme, and at the same time contains the nucleotide sequence. So here you can see the PPD. The left you can see here the orange particle. It is the telomeres. You can see the green nucleotide sequence. It is a component to the telomeres. You can say this kind of the sequence. You can say act as the temperature. Again, one times you can see elongated several nucleotides. And again, and later you can see the DNA straight. You can see bend the direction and reverse to synthesize the base pairs sequence. What mean? You can see here the right side. You can see the folding. When the DNA sequence, you can see one times, another times elongating, and when this straight, you can see burned, folding, and begin to synthesize, and back to synthesize this sequence. So here, explain for all of you. These things you can different to the other part, other DNA sequence. Telomer maintains the length of the DNA during the eukaryotic organism's chromosome DNA and keeps the stability of the chromosome. And another thing is you can see when you're shortening the length of the telomere DNA can result in the cell activity and maybe the cell activity decline and the cells synthesis. And telomerase activity is too higher. Telomere DNA is constantly extended. Cell continues divided and make cause the cancer. This I teach the introduction in the biochemistry. Introduce this. At the end of the last century, find the telomerase, and maybe many people think, and maybe quickly and shut down the all kinds of the cancer, because the telomerase activity is more higher and led to the cells change to the cancer. And later is related to so simply is more complicated, and many factors, many genes take part in the pathogenesis of the cancer. So, and two norms also it is the hard work. And another one, so you can say master in this PPD, you can say how to synthesize the mitochondrial DNA. Mitochondrial DNA, we learn it is gamma catalyzed and synthesized mitochondrial DNA. All the times, this different to the periodic organisms, you can say synthesized. All the times, maybe first synthesize the inner loop as the temperature replication. You can say here. And another thing, all the times maybe forms the stator or maybe forms the D loop, similar to the letter D. So and first you can see use the inner straight act at temperature and synthesize the base pairs straight. And furthermore, another straight you can say direct and synthesize the another one. You pay attention to the multicolorous DNA with the D loop replication model. Okay. For replication, we study this part is okay. My students, do you have some question? Okay. Next time so we begin to study another hot point in the molecular biology, the DNA damage and the DNA replication. For this part,
Okay.
for this part, and north is very hot, and find several kind of enzymes owing to the DNA molecular legacy damaged and result in this kind of the disease. And in fact, the DNA damage is very common things in the cell. But here, don't worry, the DNA damage is not too, is very heavy. All of the DNA damage can be repaired. Can be repaired. So all the times our DNA molecular legacy keep the good condition, keep the stable. Okay, this we next times we studied the DNA damage and the DNA repair and the DNA recombination. Okay, today we stopped here.
Okay, Lausha. Thank you, Lausha.
Okay.
Thank you, Lausha. Bye. Thank you, Lausha.
Bye bye, Lausha. See you.